Hey guys, this is question number 15 from Miscellaneous exercise. So, you remember the formula e raised to power log e base x is always x. So, e and log cancel each other. If here we have e raised to power log sin x base e, then this becomes sin x. So, e and log kind of cancel each other. Okay. So, this question will become, see here, this is e raised to power log of sin x. Okay, so this will become cos of cube x into sin of x dx. Okay, so this is the question. In order to solve it, can I take cos x as t? So this will become minus of sin x dx is dt. And what is sin x dx? So this is sin x dx is minus of dt. Correct? Perfect. It is minus of dt. So let me put it here. Cos x is t. So what it will become? T cube. Correct? And this will become minus of dt. This part. Now if I integrate minus of t raised to power 4 by 4 plus c. Because integration of x raised to power n dx is what? X raised to power n plus 1 by n plus 1. And what is n here in this? N is 3. Correct? So I am using this formula. So it will be n plus 1 which is 4 and n plus 1 which is 4. And what was t? T was cos x power 4 by 4 plus c. That's it. Let's see next question. So this is question 16. So you remember one formula, a log of b. So what happens? A goes behind and becomes log b raised to power a. Correct? And whenever there is no base given in the question, the base is always e if it is not mentioned. So here base is e only. So let me write e. This 3 can I take it back side? So this will be log of x cube. Correct? By this formula, a is going behind. So here 3 will go behind and it will become, and rest of it is this. Now what can we do? You remember e raised to power log whenever is anything, this e and log cancels and we have x only. So here e and log will kind of disappear. E and log, and what we will get? Only x cube. And what is this? This is nothing but x raised to power 4 plus 1, because minus 1 is nothing but this. Correct? So now my question became x cube by x 4 plus 1 dx. Perfect. What can we do now? Can I take this as t? Why? Because I feel its derivative is present in the question. See here, 4x cube plus 0 dx is dt, which is 4x cube dx is dt. Correct? So what I am getting, x cube dx is dt by 4. If you see, x cube dx is dt by 4. So let me apply dt by 4. And what is this part? This is nothing but t. Okay, so let me write it t. 1 by 4 integration of 1 by t dt. And what is integration of 1 by t? Is log of t plus c. And what was t? T was x4 plus 1. This is my answer. Next question. So this is question 17 from Miscellaneous. Okay. Can you think of something whose derivative is present in the question itself? Whose derivative is present in the question itself. So if I take f of ax plus b as t, so what is the derivative of this? f dash ax plus b. Okay, and by chain rule, see, first I've differentiated f, which is f dash, and by chain rule, what is the derivative of ax plus b? Is a into dx is dt, correct? So f dash ax plus b dx is dt by a, correct? So what I am getting here is, let me write down, it is ax plus b power n, function power n, f of dash ax plus b dx. So what I am getting, this part is nothing but dt by a, this, correct? Dt by a. So let me write down is equal to, this is t raised to power n, because this I have assumed as t, this part. So this is t raised to power n into dt by a. 1 by a is out, t raised to power n dt. So what is integration of this? T raised to power n plus 1 by n plus 1 plus c. And what was t? T was this. I will put it back. F of ax plus b power n plus 1 by n plus 1 plus c. This is my answer. I hope you understood. 18th. This is important question and a slightly tricky question. See here. What is sine a plus b? What is sine a plus b formula? Is sine a cos b plus cos a sine b. So can I use it here? Okay. So let me write it. So it will be under root of, this is sine cube x into, this will be, okay, I applied this formula here, sin x cos a, cos x sin a. Now, can I take sin x common here and here? So whenever we take something common, it is divided. So here what is left after taking sine common is cos a plus, here there is no sine, so how to take common? If nothing is there, that we divide, we will divide it. Okay, if anything we have to take common, we divide, correct? So what I will get here is, here we will get under root of, what is this into this? Is a sine raised to power 4x, and this is cos a plus, cos by sine is what? This is cot x into sine a, correct? Remember in maths, a, b, c, cos a or sine a, anything like this is treated as constant. These are not treated as variables. Okay? Now, sine raised to power 4 can come out of under root. Yes or no? It can come out of under root. So what it will become? It will become sine square x and under root this, which is cos a plus cot x into sine a. Okay? And what is 1 by sine square? Reverse of sine is what? Cosec. Fine. So this will become cosec square x dx by under root of this cos a plus cot x into sine a. Correct? What can we do now? Think, what can we take t so that we get something which is in numerator? Can I take cos a plus cot x into sine a as t? Okay. Cos a is a constant, so 0. I am differentiating both sides. Differentiate both sides. So 0 plus, what is derivative of cos? Minus cosec square x into, this is just a constant term, dx is dt. So I am kind of getting it here. Correct? I am getting this and this. Only this is extra. So what can I write? Cosec square x dx is minus dt by a. This minus and sine A. I'm sorry, this is sine A. I am taking other side. Correct? I hope you got it. What I did is cosec square and dx I kept this side only. Minus and this I am taking other side. So see here, this is nothing but I am getting this. Correct? So let me put it, integration of minus dt by sine A, and this will become under root of t, because this I have considered as t. So this is 1 by sine A integration of t raised to power minus half dt. There is a formula, root of x dx integration is, integration of dx by root x is 2 root x. This is a formula, okay, is 2 root x. It came out from basic formula only, but it is useful at many places. So memorize it. Integration of dx by root x is 2 root x. So I can use it here. So I will get minus 1 by sine A into twice of root of t plus c. And what was t? T was taken as this thing. T was this. Correct? So let me write down cos A plus cot x into sine A. So this is my answer. Next question. This is question 19. This is a little bit of lengthy question. Okay. First of all, observe this. What do you think of this? This looks like an inverse formula. Sine inverse of x, cos inverse of x is always pi by 2. Right? This is a formula from inverse trick. So I can use it here. Okay. Second thing, from here, can I write cos inverse x is pi by 2 minus sine of inverse of root x. Is it fine? Okay. The cos inverse of this is equal to pi by 2 minus of sine inverse of root x. Okay, let me use it here. Top part I am just not changing. Top part as it is. This is nothing but pi by 2 dx. So this will reverse and come up 2 by pi. Correct? This will be reverse and come in front. This is sine inverse of root x minus this thing. Can I write pi by 2 minus sine inverse of root x? Can I write this? Perfect. So what we will get now? If I open this, this will be sine inverse of root x minus pi by 2 plus, this minus will become plus sine inverse root x dx. Correct? Okay. What is this plus this? Is, what is this plus this is 2 by pi twice of sine inverse of root x minus pi by 2 dx. If I multiply this inside, it will be 4 by pi integration of sine inverse of root x dx minus integration of 1 dx. So this will be 4 by pi. This I will solve separately. Let me call it integration minus of, integration of 1 is what? X plus c. Now question is how to integrate this part. Integration of sine inverse x. So to integrate of inverse functions, how to solve it? See here. Can I take root x as t to make it simple? Okay. So that means x will be t square. We are just assuming here to simplify it. Okay. So what will be dx? dx will be 2t dt. Correct? So this I am putting in my question. So this will become sine inverse of t, and what is dx? Twice of t dt. Correct? So in this part is inverse trig and this is algebra. So this is looking like product of two functions. For some functions we use ILATE method. ILATE is used when there is a product of two functions. I is for inverse trig. Okay. This is for log. A is for algebraic functions. T is for trigonometric functions. And E is for exponent functions. So this is the order in which we solve it. So inverse is given first priority, log second, third algebra, fourth trig, and fifth exponent. So here this is inverse and this is algebra. So inverse will be given first priority and algebra will come later. So let me write down. This is something like this into t dt. So this is first and this is second function. So this is called u and this is v. And what is u into v formula in integration? The formula is, write it carefully, u as it is, integration of v minus derivative of first, integration of second, and integration of this whole thing. This is the formula. To remember it carefully. This is what we use for u into v. Okay. So I will apply here this. Okay. So u means sine inverse as it is, integration of d minus derivative of first. So what is derivative of this? 1 by root of 1 minus t square, derivative of sine inverse, into integration of t, integration of whole. So let me write sine inverse t, integration of t is t square by 2 minus 1 by under root of 1 minus t square. And what is integration of this? T square by 2 dt. Okay. One thing you remember, we had 2 in front, this 2. So this is still there. This 2 is still there. And this 2 will cancel with this. Correct? Because these 2 are in denominator and this is in numerator. So this will cancel. So what I am getting now is t square sine inverse of t minus integration of t square dt by root of 1 minus t square. So this is done. First part is done. Second part we need to think what to do with the second part. So here I will use some manipulation. Let me write down. This minus can I take inside? So this will become minus of t square. Okay. So let me write it. Sine inverse t plus minus of t square dt by this. Here can I do plus 1 and minus 1? This is plus 1 and this is minus 1. We can do that. And then separate out. This part separate and this part separate. Okay. Let me do it. T square sine inverse of t plus integration of this part 1 minus t square by root of 1 minus t square minus 1 by 1 minus t square dt. So these two parts I have separated, this and this. Now what can we do? So this I will simply copy, sine inverse t plus, what is this? Integration of root of 1 minus t square dt minus What is integration of this? This is a standard formula. This is nothing but sine inverse of t. Okay, integration of this. And for this part, integration of, there is a standard formula, 1 square minus x square dx. The formula says actually a square minus x square is equal to x by 2 under root of a square minus x square plus a square by 2 sine inverse x by a. This is the formula that you have to memorize. So this form is matching with this. Only thing is here is 1. So can I write it 1 square? And a is 1 here. According to this. So this will become t square sine inverse of t, first term, plus now I am integrating this term considering a is 1. So it will be t by 2 integration of 1 minus t square plus a square is 1 by 2 sine inverse of t by a, and a is 1 only, minus, what is this? The third term is nothing but sine inverse of t. So if I simplify, it will become sine inverse of t by 2, 1 minus t square, and what is this minus this is nothing but half minus sine inverse t is minus of half sine inverse t, correct? Plus c, actually c will be everywhere, you can add it in the end. Okay, in these two terms sine inverse is common, so let me write t square minus half sine inverse t plus t by 2, 1 minus t square. And if you remember, what was t? So t was root x and t square was x. So let me just put x minus half sine inverse root of x, root x by 2, root f 1 minus x plus c. So this was that I part that we were solving. So this was a little bit lengthy question, but I hope you understood. This was question 19. See you in next video. Please share, like and subscribe. Thank you everyone.